Kia ora team, welcome to this little tutorial on trigonometry. You need to be really familiar with this skill because this comes in handy for physics, okay? So the three functions you need to know is so katoa. This is a useful acronym to help you figure out what equation to use. So, starting off with the first question, we want to figure out this side over here, x. Before we do anything, it's important to label our sides, okay? So, starting off with the hypotenuse, this is going to be the longest side, which in this case is this edge over here. We've got this is our adjacent. Our adjacent is always going to be in between the right angle and another angle, okay? So that's our adjacent. The next thing that we've got is our opposite, because it's opposite an angle over here. Okay, so what function do we have to use? Well, we've been given a, so we have to use an equation with a in it, and we're trying to find o. So we need to use an equation with a and o. Which function has a and o? It's our tan function, toa. So the equation that we'll be using is tan theta o over a. Let's use that. Tan theta equals o over a, toa. Alright, so let's substitute everything in. Our theta is our angle that we're dealing with, which in this case is 67 degrees. Always use the angles that's attached to either the A or the O, okay? Ooh, 5%, we better be speedy. O, which in this case is unknown, over our adjacent, which is 2 meters. Now we want to get the opposite by itself, okay? We want the O by itself, so we have to get rid of the 2. The way we get rid of 2, because it's currently being divided by 2, we have to get rid of it by timesing by 2, because that's the opposite of divide. So that cancels it out. What we do on one side of the equal sign, we have to do to the other. So writing that out nice and neatly, we've got O equals 2 times tan 67. Let's plug that into our calculator. 2 times tan equals 67. And that gives us 4.7 bananas. Nope. Everything's measured in meters here for this question. So that's our unit that we're dealing with. Okay, so this side over here is equal to 4.7 meters. And I've done that answer to 2 decimal places. All right, next question. I think we've got a good grip on this, so let's speed through these questions because I'm only on 5%. So let's label the triangle real quick. We've got our hypotenuse, we've got our adjacent, and then we've got our opposite. The sides of concern, well, we want to figure out what our A is, and we've been given H. What is an equation with A and H? Yep, it's our cosine equation, ka, which has A and H. So cos theta equals A over H. Cos theta, what's our angle that we're dealing with? It's this one here. 30 equals A, which is unknown, over H, which is given to us, and that's 5. To get A by itself, we have to get rid of the 5 by timesing it by itself. That means we times the other side by itself. Writing that neatly, we've got A equals 5 times cos 30. Plugging that into our calculator, we've got 5 times cos 30. And that is 4.3 meters. Let me just double check the answer there. Yeah, correct. Okay, next one. Let's see if you can beat me to it. Okay, we've got our hypotenuse, we've got our opposite, and we've got, sorry, actually that's meant to be our adjacent, and we've got our opposite here. Alright, now, angles that we're dealing with, the sides that we're dealing with, sorry, are our hypotenuse and our adjacent, A and H. Which one has A and H? Again, that's our cosine function. So we've got cos equals A over H, ka. Cos, what's the angle that we're dealing with? It's 71. Equals A, which is unknown, over H, which is 24. To get A by itself, we need to get rid of the 24. That means we have to do it to this side as well. So writing that neatly, that becomes A equals 24 times cos 71. Plugging that into the calculator, we've got 24 times cos 71. And that gives us A is equal to 7.8 meters. Let's double check our answer there. 7.8 meters, well done. Okay, next one, zooming through these. We've got our H, we've got our A, we've got our O. We want to figure out what O is, and we have been given H. What is the equation which has O and H? So we have to use the sine function. So sine theta equals O over H, so. Plugging everything in, the angle that we're dealing with is 64. So it's this angle because it's attached to H, okay? O Alright, so we want to get O by itself, so we need to get rid of this 41.9. That means we have to times this side by 41.9. And so, rewrite this neatly as O equals 41.9 times sine 64. Plug that into our calculator. We've got 41.9. Oh my goodness, 41.9 sine 64, and that is equal to 37.6. Round that up to 7 centimeters. So this side here is 37.7 centimeters. Let's double check our answer. 37.7. Ooh. They wrote meters, but it should have been centimeters. But we got that correct. Okay. Next question. E. Label the sides. H. We've got our opposite, and we've got our adjacent in between these two angles. Okay, so what are the sides of concern? Well, we've got the opposite, which is unknown. We want to find that out. And we've got our hypotenuse, which is what we've been given. So O and H. Which function has O and H? Yep, that's our so. It has O and H. So the function we're using is sine. Sine theta equals O over H. So. Alright, sine, let's substitute everything in. Sine theta, which is in this case 38, equals O, which is unknown, and H, which is 7.5. Rearrange to find what O is, the opposite. We do that by getting rid of the 7.5, timesing it to the other side, and rewriting it neatly as O equals 7.5 times sine 38. What is that going to equal? Well, plug that into our calculator because I cannot mental math that. 7.5 sine 38. That is equal to 4.6 meters. Okay, highlight that. Check our answer. Boom. Next one. Label the triangle. Go. Race me. See if you can do it before me. Otherwise, pause me. Okay. Hypotenuse. Adjacent. Opposite. Sweet. What are the sides of concern? Well, we've got an adjacent that we need to figure out. And we've been given our h. Which equation has a and h? Yep, that's our cosine equation. Let's use that. Cos theta equals a over h. Substitute everything in. Angle that we're dealing with is 62 equals a, which is unknown, over h, 8.6. We need to get rid of, I might move this across slightly. There we go, more space to write. To get rid of 8.6 and have a all by itself, we need to times it by itself because it's currently being divided, and the opposite of divide is times. That means we have to times the other side by the same thing. It's all symmetrical here. Okay, writing that neatly so we can process this nicely. It's a equals 8.6 times cos 62. 8.6 times cos 62 is 4.0 meters. Shall we check our answer? Oh, moment of truth. What one was that one? F. Oh, thank God. All right. Next question, second to last one. Hopefully my battery lasts. Label the triangle. H. I'm having a brain blank. Whew, that was an A. And this is the opposite. There we go. Angles or sides of concern. Well, we want to find out what O is, and we've been given H. O and H. Which equation has O and H? Yep, that's our SAW equation. So we're using sine theta equals O over H. Sine theta, what's our angle that we're dealing with? 37. O, which is what we're trying to find out, over H, which is 70. We want to get O by itself, so let's get rid of the 70, eh? Times this side by 70, that means we times this side by 70. So, writing this neatly, we've got O equals 70 times sine 37. O equals, let's type this into our calculator, 70 times sine 37. Oops, I just double bracketed. And that's 42.1 centimeters. Did you remember units? Because that could be the difference between right and wrong. I'm confident we got that right, so I'm going to highlight that. Oh, thank God. Okay, last one. Label the triangle. Go on. Did you get that correct? I hope so. Sides of concern. Adjacent is what we've been given, and we want to figure out what O is. What equation has O and A? Yup, it's our TOA equation, aka our tan equation. O over A. Substitute everything in. Cool? Get O by itself. Rewrite it nicely. Ooh, grey. Stick with black. Plug it into our calculator. And we get 2.1, ooh, let's round it. 2.2 for 2 decimal places. Units is meters. Oh, we better get this correct. I'm so sure we smashed it, team. And we've got all of those correct. I hope this has made sense. Good practice for you. And we made it within my 5% battery percentage. Whoop, whoop. Okay, see you later.